Hello, welcome to the third part of section 6.3 partial fractions. In my previous videos, I went over the first three cases and we just have to go over the last case. The case where I have a prime quadratic polynomial raised to a power, meaning repeated factors. Then what we're going to do is our partial fraction decomposition will have the same factor raised to every single power starting at 1 all the way to the power of my factor in the denominator, okay? And then on top of that, keep in mind that whenever we have a quadratic polynomial in the denominator, then the numerator has to have a linear polynomial, okay? So when you factor the denominator, you're going to have factors that are linear and factors that are quadratic. Every single linear factor will have a constant in the denominator, and then if we have quadratic factors like prime quadratic polynomials, then on top you'll have linear. So then keep in mind one more time, the numerator is always 1 degree less than the denominator. Okay, let's do an example. So as I was saying, that's the case we're going to look at now. And then, of course, keep in mind that by irreducible, I mean that b squared minus 4ac is less than 0. Okay, perfect. So let's do this. Here I have this integral. I have the integral of x to the fourth over x times x squared plus 1 squared. So in this case, our denominator has been factored already. Okay, so we see that we have here linear, and then we have the quadratic but squared. Okay, so one more time, we have a repeated squared or repeated quadratic polynomial here. Okay, so let's do this. So I'm going to set up. So usually the first step is to factor the denominator, but we already have that. So I'm going to skip first step and then go straight to the second step, which I'm going to call, I'm just going to say step 2, well, step 1, whatever. Step 1, factor denominator, which as I said before, we already have it, so it's fine, plus 1, we have it. So step 2, let me set up my decomposition, right? So I know that x to the fourth plus 1 is over x times x squared plus 1 squared. So I know that for the linear term, I get a over x. And then the quadratic term, since we know that we have x squared plus 1, we know that we cannot factor this in the real numbers, then I'm going to get plus, well, some linear polynomial on top over x squared plus 1 to the first power. And then I'm going to go all the way to 2. So one more, ex plus f over x squared plus 1 squared. And then one more time. If instead of squared, we had here cubed, right, to the third power, then we would need one extra term, like whatever, gx plus h over x squared plus 1 cubed, okay? But that's not the case. All right, so this is what we have. And then as usual, the next step is to multiply everything by the least common multiple of the denominator, which is x times x squared plus 1 squared. What do I get? Well, I get x to the fourth plus 1 on the left-hand side, plus if I multiply x times x squared plus 1 squared by this, that cancels this, and I get that this is just a, and then x squared plus 1 squared, and then plus if I multiply this by this, I cancel one of the x squared plus 1, so I'm left with bx plus d times x times, let me just write it like this, times x squared plus 1. And then finally, if I multiply ex plus f divided by x squared plus 1 squared by this, I cancel my x squared plus 1 squared and I get x back, okay? Perfect, okay. So now at this step, this is when I usually look for anything that I can cancel, but in this case, everything is positive. So it's, everything is positive and squares, and it's kind of hard, but you can still try. For example, look at it. Like say, if I let x be equal to 0, then that goes away, this goes away, and I'm left with this. So let's do that. Let's keep doing that where if you see something that's super easy, just plug it in and see what happens. So let x be equal to 0. And again, I can do this because I know that this equality has to be true for every single value of x. So in particular, if I let x be equal to 0, and I get that this is, well, 0 to the fourth power plus 1, so I get 1 on the left-hand side, and that's equal to, well, here now, 0 squared plus 1, I get 1 times a, so I get a, and then this one goes away, and this one goes away, so now I know that a is equal to 1. The beauty of that is that since a is equal to 1, now I can just take advantage of that, okay, and replace here I can replace a equals 1. Okay, so I'm going to take this with me, okay, and say here now that we know that a is equal to 1, I'm going to put it here. So a is equal to 1. Okay, awesome. Is there anything else we can do? Then there's nothing else we can do. So then we have to go back and factor, expand, simplify the right-hand side, and then set the coefficients of the terms in the right-hand side to the coefficients of the terms in the left-hand side. What do I mean by that? Let me do it real quick. So from here, I see that x to the fourth plus 1, it's equal to, I'm going to expand x squared plus 1, so I get that this is x to the fourth plus 2x squared plus 1, plus I'm going to multiply all this thing together, so I get that that is just bx times x squared. We have bx to the fourth plus bx times x times 1. I get plus bx squared, and then plus, well, d times x squared, I get dx cubed, and then d times x times 1, I get dx, so plus dx, and then my last term, I get ex squared plus fx. So let me take a look, make sure that this is correct, because I'm not great at multiplying simple numbers. Okay, bx squared, c. Oh, it's fine. Really, I also don't know the alphabet, okay? Because I did bx plus d instead of bx plus c. It's a, b, c, and then d, but whatever, okay? We're looking for the values of this, oh my God, of this constants, okay? So it's okay, it's all good. So let's do this. So then, as we always do, I'm going to combine like terms. So left-hand side stays the same, and now I'm going to take care of my x to the fourth term. So I have x to the fourth, and then plus bx to the fourth. So I get that this is equal to, what do I get? I get 1 plus b, and then x to the fourth, and then I get x to the fourth. Now I'm going to take care of x cubed, so I have dx cubed, and that's it, dx cubed, and that's it, dx cubed, and that is it. So I get plus dx cubed, and then I get the square, so I have 2x squared, ex squared, and bx squared. So I have that this is plus 2 plus b plus e, and then x squared. Then move on to the linear terms. So for the linear terms, I have dx and fx, so I have plus d plus fx, and then finally my constant term, well, the constant term, it's equal to 1, so plus 1, well, we know that, okay? We know that. All right, so now, one more time, I know that since the left-hand side is equal to the right-hand side, then 1 plus b, the coefficient of x squared, has to be equal to the coefficient of x squared. So from there, I know that 1 plus b must be equal to 1. Therefore, b is equal to 0. So we have the value of b. Then we see that dx cubed is equal to, well, there are no cubic terms here. So then d has to be 0. So then d is equal to 0. Then we have 2 plus b plus e. Then again, there are no quadratic terms here. So then 2 plus b plus e has to be equal to 0. So here we go. 2 plus b plus e must be 0, but we know that b is equal to 0. So this is 2 plus e is equal to 0. Therefore, e is equal to -2. Okay? Then we have d plus f. Well, we also have no linear terms, so d plus f has to be 0 as well. So d plus f is equal to 0, but we know that d is equal to 0, so f is equal to 0. And then finally, we have that 1 is equal to 1 as expected. So now I can take the values of B, D, E, and F, and again, I don't know why I didn't write C down, but I'm not re-recording this. So I take these values, and now on my third step, as usual, I am ready to compute my integral. So I'm going to take the original integral with me, right? So I'm going to take this with me because I think it's so much easier. Copy, and then and then paste. So then keep in mind that we're using the fact that I can write this rational function as using the partial fraction decomposition. So then the integral of x to the fourth plus 1 over x times x squared plus 1 squared dx is just equal to the integral of this partial fraction decomposition. And then let me see. So a is equal to 1. So a is equal to 1. So this is 1. Then what else do we have? Let me take it with me so I don't have to keep like doing that. Okay, so then b is equal to 0. So copy, and this is just for reference. Okay. So then b is equal to 0. So then this is 0. Then d is equal to 0. So then this whole term goes away. And then e is equal to -2, f is equal to 0, so I get here -2 over x squared plus 1 squared dx. Okay, perfect. So now I'm ready to compute my integrals, right? So this is step 3 where we're computing the integrals. So this is just the integral of 1 over x dx minus 2 times the integral of x over x squared plus 1 squared dx. The first one, we know this is just the natural log of x. And then for the second one, we need u substitution. So let's do it real quick, right? So if we say, well, let u be equal to x squared plus 1, then du is equal to 2x dx. Therefore, du divided by 2 is x dx. So I can rewrite my integral as, well, -2, the integral of x dx, which is just du divided by 2, over times 1 over u squared, which I will conveniently write as u to the -2. So u to the -2, okay? So then I'm ready for this. I get the natural log of x minus 2 over 2, and then u to the -2 plus 1. So I get -1 divided by -1, and then plus a constant, and I'm ready to go back to x and ready to simplify this expression. So my final answer is the integral of x to the fourth plus 1 over x times x squared plus 1 squared is equal to, well, the natural log of x. And then here, that is 1. And this negative with this negative, we get something positive. So this is plus 1 over, well, u, which is x squared plus 1 plus c. One more time. Here, I had to go back to x. U is equal to x squared plus 1. So that is my final answer, okay? I hope this makes sense. I hope you see the pattern and you really understand what's going on. I have one more video about partial fraction decomposition, okay? Bye-bye.